Hello people, welcome back to the corgi64 project where we're building a simulated computer from scratch. When we last left off, we built a very minimal working CPU. So we actually were able to read instructions from our memory and execute them on our CPU. What we're going to do this time is a little bit of cleanup, and we're going to add more functionality. So we're going to start adding more of these opcodes to our CPU. And in fact, what we're going to do is we're going to take a look at, let's see, we're going to take a look at starting to load information from memory. So instead of setting a register from immediate value, we're going to be able to set a register from a value at an address in memory. So that will allow us to grab values from memory. And we're going to do that in our cpu.h file. Now, before we get to doing that, before we get to adding these three load commands and testing them, we're going to actually go back and look at this local thing, which we had defined from being static, the static keyword. And since we've have all of our implementation in an H file, we don't really need this, because if we include, or when we include our cpu.h file in our main file here, it actually is essentially like a copy and paste. And what static does when it's put in front of a function is it makes the function visible only within the file that it's within the file that the function exists in. Now, if we use include, it's as if this cpu.h file exists in our main.cpp file, and we don't have, we're not hiding anything from our main function here. So what we're going to do is we're going to just eliminate this and allow ourselves to be a little bit more, allow our system to be a little bit more simple. So we're going to go ahead and we're going to find all the local instances, local with the space, and then we'll go ahead and replace it with nothing. So if we do that, we actually get rid of all the local stuff, and now we just have our void functions, and that's great. So now we can actually get back to implementing these LDA, LDB, and LDC opcodes. So go back to the cpu.h, and let's just carve out a space here. We've got some register opcodes. Let's create some memory opcodes, and we'll say memory opcodes. And we'll create some functions here. We'll have void LDA, give it a pointer to the CPU, and that should be pretty good. So what we'll do is the A register will actually end up being loaded from a place in memory. So we're going to grab a place in memory, and the place in memory is actually, let's see, where will we get that address? So the address in memory, we'll actually get it from our instruction. So if we go to our instruction, we're going to grab a value, and that will be the value of the memory. So we grab, so this will be a memory address that will be stored in our instruction. We're going to grab that address of that memory, or grab the value at that address in memory, and then set it to our A register value. So that's pretty good. Let's go ahead and copy that a couple times so we can actually have loading register B and register C here, and then not forget to do this. So we're actually loading the register B and the register C, and that should be pretty good. Let's go back over to, we haven't written any tests in a while. We should probably write some tests for these and make sure that they work. So let's go back to tests.cpp, and we'll write some tests for these things. So we'll do, we'll just put it right down here. We'll have some tests for loading values from memory. And we'll create a void test LDA, give it a pointer to a CPU, and we'll have a couple of these, but let's just write it first. So what we're going to do is we're going to actually just we're actually going to set a let's see, what we want to do is we want to set up our memory with some value, and then we want to load it into the register. So in our main function, what we should do is we should actually give our main function some memory that we can work with. So let's just give it, I don't know, 16 slots of memory, 16 bytes. That might be good enough. Maybe a little bit more, or maybe we'll give it 32 slots. So what we'll do is we init the CPU and we'll create some memory. So we'll have a byte for memory, and we'll give it 32 slots. And I believe, hopefully, in Microsoft Visual Studio's compiler, this will set all those places in memory to zeros. Hopefully. If it doesn't matter too much. So what we're going to do is, now that we have that memory, let's actually set that memory to our CPU. So we'll have our CPU memory is this memory that we created here. And now we can go back to our test. So we can say, okay, our CPU memory, starting at a certain spot, let's see, what should we do here? We should actually have, okay, yeah, we'll set it this way. We'll just, to make it easily legible, what we'll do is we'll just set the values, or the places in memory, to certain values in memory. So we're going to set it to a hexadecimal value. Let's just set it to a value of 3. And since all the rest of the values are 0, we should have a value of 3 in memory. So let's go ahead and test our LDA function and give it our CPU. And what we should do, what we need to do here is we also need to set our instruction register, right? So we need to say where we need to pull this value from memory, and it starts at 0, right? And in fact, what we do, if you remember, the way that our memory is set up, when we pull in an instruction, we actually have an opcode, and then we also have a value. So if you go to cpu.h, let's take a look at this. The way that our instructions look is we have an opcode, and then we also have a value. And the only thing that we're going to test is actually just grabbing a value and making sure that it gets into the CPU. So the way that we're going to do that is we can't actually set the first one to 3. We should set the second byte in memory, right? The first byte we don't really care about. It will become an instruction, and the opcode will just be 0, but we're not going to use the opcode in our test. All that we care about is this 64-byte or 64-bit value. And so we're going to set that to 3, because remember, the first byte will be 0, the second byte will be 3, and then all the rest of the bytes should be 0, which means when we read in the value, it should be 3. So let's go ahead and set our instruction register, and the instruction register will have a value, let's see, a value of 0, right? Because we're going to want to read the instruction starting at address 0, and this will give us our value. So now we've set up our memory, we've set up our instruction register, and then we can do the load. So this should take the starting at this load should actually load a value from our basically the first the first location in memory into our A register. All right, so let's take a look at that. In fact, maybe we could actually get away with not having, actually we're not even reading this place in memory, so we could probably actually set this to 0, and then we'll read the value at 0, and that should be good, right? Well, let's see. So LDA, what is LDA going to do? LDA is going to take, let's go to cpu.h here, just to make sure that we don't confuse ourselves, because you can think about this, you can overthink it too much. So what we're going to do is we're going to get the instruction register, we're going to get a value. So it's as if we already have read that thing in memory. So let's So if we go here to our test, we're not actually reading anything from memory. We're just reading from our instruction value, which already read something from memory. So the instruction value is going to be 3, and we're going to have that load into register A. So essentially, we're just going to be reading from our instruction register. So this should actually be good enough for a test, and then we can go here, down here, and say test load memory opcodes, and we'll say test LDB with C, and we'll see what happens there. In fact, we should probably print out, let's see, we have the register printing now, so maybe what we should do is we should print out, maybe we should print out all of our registers, right? So remember back a while ago, up here, we actually wrote our CPU print status, which prints out the value of all of our registers. We can do that now. In fact, we should probably set up all of our tests to print out the status of all the registers, so that way we can take a look at these things. Instead of having this ad hoc print function, we can actually just print out the status of our CPU. And so we'll give it a pointer to our CPU. I believe that's the that's the function signature. So we can do CPU print status, and in fact, we can replace all of these printfs that we had before with our print CPU status, or CPU print status. And that's what we're going to do. Let's go ahead and just do that right now. Now we won't have to worry about writing custom print functions or print statements every single time. We'll just print out our CPU status. So let's do that. We'll have a print. We'll do all these things. Here we go. Replace this, and we're almost there. There we go. So it looks like we've replaced all of them. We've set up our test. Let's see if we can run our test. So let's go ahead and build tests, and it looks like test LDB identifier not found. So it looks like I made a typo. So LDA, that's what we're testing, not B. We're testing A. So let's do that. We'll build the tests. Looks like we built properly. Let's do tests.exe, and it looks like all tests passed. And in fact, what we should do is maybe run, yeah, so each one of these things, it starts with A, B, C, PC, SP. We get our flags, and then we get ABC. So that's what we get. If we look at the A at the very end, because we're testing LDA, right, we should be able to see that we should be loading 3 into A, right? That's what we should be doing if we did our if we did everything correctly. So if we do LDA, right, we should be taking this instruction value, which is 3, and it should be putting that into register A, right? Because now we'll obviously have, oh, looks like we have 3 from here, but maybe that's from a previous version of things. So let's actually change this number, because we're using 3 a lot in our tests. So let's actually set this to 12 or 17. 17 doesn't appear at all in any of our systems yet. So let's go ahead and build our test, and we'll run our test. And it looks like it's not really working. We're not setting register A to be the value from our instruction. So let's go back here and see what we can figure out. So this LDA takes a CPU pointer. We should have the register A should get from memory value. Oh, this actually should just be the value. It's not memory, the memory value. That is 0, right? We should actually be getting the value from our instruction register, right? Or is that correct? Let's see. Oh, yes, yes. So if we're loading a value from memory, right? We should be getting it from our instruction. Okay, so this is actually correct. What I did is I actually set up my test incorrectly. So I actually had it a little bit better the first time. So let's go to our test. So the test LDA, we actually do need to set up our memory value, right? So our instruction value will be the address that we're looking at. So we'll set the address to 0. In fact, we can set it to this if we want everything to be in hexadecimal. But we also want to set up our memory value. So we'll set the memory at address 0 to be, say, I don't know, let's see, if we want to put it in hexadecimal, then what we're going to do is we're going to set that first byte. Well, actually, we don't need to set it up in hexadecimal. Let's just set it up for 17. That way we don't have to worry about converting stuff to hexadecimal. Since this is just the first byte, I can just put this in regular decimal, and it'll be easy for us to read. So if we build this, we can build our tests, we can run our tests, and it looks like it works. So we actually took the, we looked at the first byte, the 0th byte in memory, which happened to be 17, and we load that into the address A. Right? Now, maybe what we should do is check and see if it's actually reading the entire, because it looks like we aren't reading a 64, it looks like we aren't reading 64 bits here, we're just reading 1 byte, and we're setting it into the A value. So probably what we want to do here, so we can actually do a test and make it fail. Oh, we did not even do an assertion. What we should be doing is asserting that the A register equals 17 here, right? That's what we want. But what we should do is we should be testing if this actually reads all 64, or that it's reading 64 bits worth of stuff. So let's actually go here, and we'll put a 1 here, and we'll do a memory, and the first byte, we'll make that a 1 too. So we should actually get a much higher value here. So we should actually be looking for a 256 value, I think. And I think this is going to fail because we should be getting 256 if I didn't make any mistakes. But it should fail, right? So we built, and then we run, and it looks like we did fail because we're only getting a 3 here. So, and we were expecting a 256, right? And that's the reason why, is because we're in Little Endian, so we've got a 1 here, which will be a 1, and then we have a 1 in the second byte's place, which is the 7th bit or the 9th bit. So that should give us 255 value, or maybe 256. So maybe this should be 257 or something like that. But we're not reading. We're only reading 1 byte here. So let's go ahead and fix this to be a i64 pointer, and I believe that's how we were doing this before. So when we read, yes, so we get our C memory, and then we'll actually get an offset from that. So let's actually do that. So we'll get our C memory, and we'll actually look at a byte offset of that, and probably we should put that in parentheses. Yes, we should. So let's go ahead and do that. So we're going to look at this instruction value will be an offset, so this will be an address, and it will be an offset from the beginning of memory, and we'll read 64 bits worth, and we'll read it as a pointer to that, right? And then we'll dereference that pointer to give us a 64-bit value, right? So let's go ahead and copy this, because if this works, we'll want to have all of this replace that as well. So we'll want the same behavior. So let's do that. Then we can go back over here. We can run our build test. It looks like I have some, let's see, I have some, let's see, illegal use of this type as an expression. Oh, it looks like I have some syntax errors, so let's look at CPU h.70. So what did I do incorrectly here? So we've got i64. Oh, see, this should be like this, so we shouldn't be parentheses in the wrong place. So there we go, because this doesn't make any sense, so we move that over. So this should be a little bit better. Looks like we built correctly, and if we run things, we're still not we still didn't get the right thing that we wanted, but I think perhaps we should be looking for the 257 value or something like that, but it looks like we're getting 3, which that doesn't really make any sense. Or it looks like we've got 3, which is the same value that we had in our previous test. So it looks like we're not actually setting the value in register A. So let's see. So C instruction value. We can actually take this apart and take a look at it. So the address to look at, that should be, actually this is printf, right? And this will be an integer value. In fact, it's a 64-bit value, so I think it's an LLD. So let's do C instruction value. And then what we'll do is we'll also look at CA after this. So we'll do printf. We'll look at register C, and this will be a 64-bit value. So that should be LLD. Let's put some new lines after this, and we'll print out CA, and we'll build. We'll run. Obviously so 257 is what we're looking for. Yes, so that's because first byte set to a 1 should be 256 plus 1. So this should be 257. And then, so if we build again, we run, and it looks like we're good. And I think the reason why we're seeing C before is that this assert was running, it was breaking, and then obviously if we're going to print out, if this goes beyond that and it prints out, oh, if it stops, it'll be whatever this previous test was. And the previous test had a 3 in the register A. So yeah, there we go. We actually have a running register. What is this? Register C? Why am I looking at register C? Oh, because I used probably the wrong, it's a register A is what it really is. So it's just the wrong label. So if we do that build, we run the test, register A is 257, and register A is 257 afterwards. So we can take these testing print statements away, and now we have an actual working system. So all of these instructions should be the same here and here, which means that we can copy these tests. We should be able to have a test for LDB and LDC. So this is LDB, and we'll set this to 2. We'll set this to 3. And this will be LDB, and this will be LDC. And then we're going to assert that register B is a certain number, and register C is a certain number, and the register B number should be 258, and the register C should be 259. And then we can actually run these tests, right? So we can copy this, and B, C, make sure that we save, and then we can build our tests. What did I do? I made an error. Let's see. Already has a body. Okay, so I didn't change the name up here. I have a duplicate. This one should be LDC. So let's build the tests. Whoops. Build the tests. Build test.bat. Okay, there we go. Then we can run the executable. And we have 250. Wait, what? A250. Okay, A is 257. Next one 258, and C is 259. So that looks pretty good. So you got to see a little bit about what it's like to add more functionality onto this thing. You also got to see what it's like to do a little bit of troubleshooting in real time. Of when you make some mistakes, you can read the error messages that come out here. Look at the stack dump, and then you can go to the line and see what you did wrong and try to figure it out. And you can also see how we kind of thought things through with how to deal with this memory stuff. So thank you for watching. I think next time what we'll do is we'll continue on. We'll create a little bit more. We'll want to store stuff back to memory. So we've learned how to set immediate values. We've learned how to load values from memory. Now we need to put values back into memory. So then we'll be able to basically take stuff from memory, perform computations on it, and store it back into memory. And that is the very basics of getting a CPU running and working. And from there, it's basically a lot of kind of additions that allow us to do more complicated things. But we'll have all of the major basics put into place after next time. So thank you very much for watching. Till next time.